The diameter of an atom is approximately 10 to the power of minus 10 meters, and the diameter of its nucleus is approximately 10 to the power of minus 15 meters. The magnitude of the Fermi radius constant given in the data booklet can be used to remember the diameter of a nucleus. Therefore, the ratio of the diameter of an atom to the diameter of its nucleus is 10 to the power of 5. In multiplication and division, percentage uncertainty can be found by adding all the other percentage uncertainties. To find the percentage uncertainty of the kinetic energy, add the percentage uncertainty of P twice with the percentage uncertainty of M. The answer is 10%. As an extra, here is how to solve the problem if the fractional uncertainty was given to us. Displacement is the shortest distance between 2 points. To find the magnitude of the displacement between x and y, use the Pythagoras theorem. The stone initially moves upwards with speed u and then hits the ground with speed v. Taking upwards as the positive direction, the initial momentum of the stone is mu and the final momentum is minus mv. To find the magnitude of the change in momentum, first subtract the initial momentum from the final momentum, then find its absolute value. In this case, the answer will be mv plus u. Take note that if the question asked for the change of the magnitude of momentum, you would have to subtract the absolute values of each other. The answer will be different. Let's start with the three Suvat equations with acceleration. For this question, the initial velocity u is v1, the final velocity v is v2, and the time taken t is t2 minus t1. The two equations shown here can be rearranged to get the equations in option 2 and 3. The last equation can be arranged to something similar but not the same as the equation in option 1. Therefore, only options 2 and 3 are correct. Here is the free body diagram of the rotating ball. The tension can be split into its vertical and horizontal components by using trigonometry. From this diagram, we can see that the net force of the horizontal component is T sine theta. Note that this is also the centripetal force. The question tells us that the ball is rotating along a horizontal circle. This means that there is no vertical acceleration, which means that there is no vertical resultant force. T cos theta equals mg. First, we need to determine the direction of frictional force on the block and trolley. Since the block is moving to the right, the frictional force on the block is to the left, since frictional force is always in the opposite direction to its motion. The frictional force on the trolley must be to the right from Newton's third law of motion. First, we need to find the magnitude of the frictional force. To do that, we need to focus on the trolley. Here, the resultant force that causes its acceleration is the frictional force. Since the mass and the acceleration of the trolley is given, using F equals ma, we can find the frictional force. Now back to the block. Here is the free body diagram of the block. From the vertical forces, we can derive that R equals mg. The equation of the frictional force is given in the data booklet. Substitute in R and rearrange to make the coefficient of friction the subject. Put in the values to find your answer. First, let's find the output power. The output power can be found by multiplying the efficiency with the input power. Here is a visual representation of the power going into and out of the motor. There are two ways to approach this question. First, we can calculate the gravitational potential energy gained in 1 second. Power output of 80 watts times 1 second equals 80 joules. Rearrange the equation for gravitational potential energy to make height the subject. Substitute in the values to find the answer. Another way is to divide the gravitational potential energy with time to change it to rate of gain in gravitational potential energy, which is also the output power. Likewise, rearrange to make height the subject. Substitute in the values to find the answer. Change in temperature is the same whether the units of the temperature is in degrees Celsius or Kelvin, since they both have the same scale. If you are ever unsure, always feel free to make up numbers to check. Here are two temperatures, 10 and 50 degrees Celsius. The difference is the same even when the units are changed to Kelvin. Here are all the information given to us on x. Note that the volume can be found since x is a cube. Use the equation given in the data booklet to derive an equation in terms of Q, M, and C. Here are all the information on y. The specific heat capacity and the density are the same as x since they are made from the same material. The volume is 8 times larger since the length is doubled. And lastly, when density is the same, mass is directly proportional to the volume, which makes mass of y 8 times mass of x. Rearrange the equation to make temperature rise of y the subject. Substitute in for the delta T to find your answer. Here is a pendulum in simple harmonic motion. You can solve this question using any system undergoing simple harmonic motion. When the displacement is at maximum, the velocity is 0. At 0, displacement velocity is maximum. This makes the potential energy maximum at maximum displacements and kinetic energy maximum when displacement is 0. The potential and kinetic energy would look like this on the graph. The total energy of a system is the sum of the potential energy and kinetic energy. In this case, since there is no external work done, the total energy remains constant. Ignore the line for kinetic energy and you'll have the answer for the potential and total energy. Fact: only transverse waves can be polarized. Transverse waves, such as electromagnetic waves, can be polarized. Longitudinal waves, such as sound waves, cannot be polarized. First, let's have a look at the graph. Gradient is y over x. Y is sine r and x is sine I. The question tells us that the gradient is m. The ray enters the glass from the air. Use the equation given in the data booklet to derive an equation between the refractive index and the angles. The angle in the glass is r and the angle in the air is I. Sine r over sine I is m, as we found previously. The refractive index in the air is 1. Rearrange to find the refractive index of glass in terms of m. Now let's focus on the critical angle. A critical angle occurs when the ray from a more dense medium, in this case the glass, refracts at 90 degrees to a less dense medium, in this case the air. Use the same equation from the data booklet. Now the angle in the air is 90 degrees and the angle in the glass is the critical angle. Substitute in all the information that we know. Rearrange to find the critical angle in terms of m. Here are the first 3 harmonics of a standing wave in an open and closed pipe. First, determine the wavelength in terms of the length L of the pipe. Next, use the equation given in the data booklet to find the frequency of the standing wave. The speed of sound in the pipe is given as v. The frequencies can be rearranged slightly to better see the pattern. Here we see a 1, 3, 5 pattern from one harmonic to the next. Therefore, the answer would be 2n minus 1 v over 4L. Some background information. First, here are the electric field patterns for a negative point charge and a positive point charge. The electric field is always directed towards the negative point charge and away from the positive point charge. Next, here are 2 charges. The electric field strength at a distance from the large charge can be calculated by dividing the force on the small charge by the charge of the small charge. Substitute the equation for the electrostatic force on the small charge into the previous equation. Both equations are given in the data booklet. It turns out that the electric field strength is inversely proportional to the distance squared. This equation is not in the data booklet, so make sure to have it memorized. At position A, the fields due to the 2 charges both point to the left. This means that the net electric field will always point to the left. At position D, the fields due to the 2 charges both point to the right. This means that the net electric field will always point to the right. At position C, the field due to 2Q will be greater than the field due to Q since 2Q has the greater charge and the position is closer to 2Q. As a result, the net electric field will always point to the left. In position B, the field produced by 2Q is weaker since the distance is greater. Therefore, it is possible for the two fields to have the same magnitude and cancel each other out, resulting in zero net electric field. Let's first have a closer look at the question. Same material means that the charge density is the same. Connected in series means that the current is the same. Electrons pass through both cylinders, meaning that the charged particle is also the same. All the information has been arranged here. Put these values into the equation given in the data booklet. Divide equation 1 with equation 2, cancel out, and rearrange to find your answer. Here is the same circuits shown in the diagram. Let's summarize what we know. Since lamp Y and Z are in parallel, the voltage across each bulb is equal. The sum of the voltage across lamp X and Y must equal to the EMF of the cells since both potential differences are in series. Right away, we can eliminate answer option C and D because their sum is not 20. Current passing through lamp Y and Z add up to current passing through lamp X. Current passing through lamp Y and Z are equal to each other since both lamps are identical to each other. This means that the current passing through lamp X is double the current passing through lamp Y. Use the power equation given in the data booklet to form an equation for lamp X and lamp Y. Put in the values. After combining the two equations, we can derive that the voltage across lamp Y is 4 times the voltage across lamp X. Therefore, the correct answer is 4 volts for lamp X and 16 volts for lamp Y. Derive a relationship between the speed and the radius to solve this question. The path of the electron inside the magnetic field is circular. This means that there is a centripetal force acting on the electron. There is a magnetic force on the electron since the movement of the electron is perpendicular to the magnetic field. The magnetic force on the electron acts as the centripetal force in this scenario. Use the equations given in the data booklet and simplify. Since B, Q, and M are constants, V and R will be directly proportional to each other. Therefore, the speed radius graph would look like this, where the line is linear and passes through the origin. First, some background information. When the current is directed out of the screen, the direction of the magnetic field is anti-clockwise. When the current is directed into the screen, the direction of the magnetic field is clockwise. Here we have wires P and R carrying current into the screen. Therefore, each wire will have a magnetic field in the clockwise direction around it. Let's focus on wire P. The direction of the magnetic field at Q due to wire P would be to the left. We are also told that the magnitude of the field is X. Now let's focus on wire R. The direction of the magnetic field at Q due to wire R would be upwards. The magnitude of this field at point Q will also be X since the distance between PQ and RQ are equal. Here is a diagram with both the fields at point Q. To find the resultant magnetic fields, join the two fields head to tails. The line between the very beginning and the very end is the resultant magnetic field. Use Pythagorean theorem to find the resultant magnetic field. Let's go through one force at a time. The weight acts on the center of mass and always points downwards. Normal force is always perpendicular to the surface. Since the surface here is vertical, the normal force is to the right. Frictional force always acts in the opposite direction to the motion. You can imagine that the motorcycle slips downwards if there was no frictional force. Put these forces together to find your answer. Photons are emitted when electrons in a higher energy level transitions to a lower energy level. The wavelength of the emitted photon can be seen on an emission spectrum. The energy of the photon equals to the energy difference between the energy levels. This means that the larger the difference in energy levels, the shorter the wavelength of the photon, as we can see from the equation given in the data booklet. Here is another electron transition, but this time from a higher energy level. On the emission spectrum, we can see that the emitted photons have a shorter wavelength. There are 3 relatively small energy level differences, which means we can expect to see 3 long wavelengths. There is 1 large energy level difference, which means we can expect to see 1 short wavelength. Put them together and your answer should look like this. Statement 1 and 2 can be deduced from the Rutherford-Geiger-Marsden scattering experiment. Statement 3, which refers to discrete energy levels, is deduced from emission spectrum. A reminder that a baryon is a particle made of 3 quarks and thus have a baryon number of +1. A meson is a particle made of a quark and an anti-quark and thus have a baryon number of 0. Here is the interaction between a proton and a pion. The proton is a baryon made of 2 up quarks and 1 down quark, which gives us a baryon number of +1 and charge of +1. The rest of the particles are mesons and so have a baryon number of 0. We know this as each particle consists of 1 quark and 1 anti-quark. The charge can be figured out from adding the charges of the quarks or by looking at the charge on the top right side of the particle symbol as shown with red circles here. Only the particle with the strange quark will have the strangeness of -1. All other particles do not have the strange quark and therefore will have 0 as strangeness. From the values that we wrote, we can see that the baryon number and the strangeness are violated in this interaction while the charge is conserved. Statement 1 is true. Carbon dioxide is released into the atmosphere during volcanic activity. Statement 2 is false. Carbon dioxide is dissolved in seawater. Increasing the solubility decreases the rate of global warming. And lastly, statement 3 is true. The rate at which plants take in carbon dioxide for photosynthesis decreases as the trees are cut down. First, let's derive an equation with emissivity and peak wavelength. Combine the power and intensity equation given in the data booklet. Then substitute in for temperature using Wien's displacement law. Rearrange to make the emissivity the subject. From here, we can derive that the emissivity is directly proportional to the peak wavelength to the power of 4 since everything else is a constant. This means that if the peak wavelength increases by 2, the emissivity increases by 16. This is just one way of solving the questions. Now let's move on to the calculation. Here is the summary of the information given to us. Surface X emits a radiation of peak wavelength twice that of Y. Divide the equation for X and Y. Cancel out to find your answer. The period of a pendulum can be simplified to the period directly proportional to root of the length of the pendulum. Combine this with the equation with the frequency to find the relationship between the frequency and the length of the pendulum. From this relationship, we can derive that if the length is halved, then the frequency is times √2. First, let's compare some major differences between a single slit interference pattern and a double slit interference pattern. For a single slit, the width of the central maximum is twice that of the width of the secondary maximum. And intensity of the central maximum is much greater than the intensity of the secondary maximum. These are the main 2 things you can look out for. Now let's have a look at the intensity pattern given to us in the question. The width of the maxima is consistent, and the intensity difference between the primary and secondary maxima is not very large. Therefore, this is the intensity pattern for double slit interference. Next, let's analyze the double slit intensity pattern. For slits with non-negligible width, the the intensity pattern is modulated by a single slit pattern. Here you can see the central maximum and the first minimum of the single slit pattern. The angle between the central maximum and the first minimum is the angle you use for the equation theta equals lambda over b. Make sure to take note of the other interference pattern equation. The angle here is the angle between the central maximum and another maximum. Now back to the question. The intensity pattern here is also modulated by a single slit pattern. The angle at which the first minimum is observed is around 0.15 radians. Use the equation given in the data booklet and put in 0.15 radians as the angle. By rearranging the numbers, we can see that the width of the slits is greater than the wavelength. Here is a diffraction pattern of blue light passing through a fixed diffraction grating. Since the slit separation is constant, we can simplify the equation given in the data booklet to the wavelength directly proportional to sine theta for the nth maximum. This relationship can be further simplified for when the angle theta is smaller than 90 degrees. We should also know by now that red light has a longer wavelength than blue light. This means that if red light is passed through the same fixed diffraction grating, a diffraction pattern with a greater angle theta would form. This means that the color violet with the shortest wavelength would be closest to the center, and the color red with the longest wavelength would be furthest away. The center would be white since all the colors are present. The source moves away from a stationary observer. Here is the equation given in the data booklet for a moving source and stationary observer. Since the source is moving away from the observer, we need to use plus in the denominator. Substitute the speed of the source and simplify to find your answer. The equation for the gravitational field strength is given in the data booklet. The gravitational field due to P is towards the left, and gravitational field due to Q is towards the right. Subtract the two gravitational field strengths to find the net gravitational field strength. We subtract them since the fields point in opposite directions. The order in which you subtract does not matter since we are only interested in the magnitude. Similarly, use the equation for gravitational potential given in the data booklet to find the gravitational potential due to P and Q separately. Since potential is a scalar, add the two potentials to find your answer. An electron is stationary between two charged plates. The only situation that this is possible is when the electrostatic force on the electron is towards the top of the plate. This will cancel out the downward weight, causing the electron to have a net force of 0. This means that the top of the plate is positively charged and the bottom of the plate is negatively charged. The direction of the electric field is always from positive to negative. Therefore, the direction of the electric field is downwards. You can also memorize that the direction of the electric field is always in the same direction of the electrostatic force on a positive charge and opposite direction of the electrostatic force on a negative charge. The electric field strength is found by dividing the potential difference between the two plates with the distance between the two plates. Therefore, the electric field strength is V over D. The kinetic energy of a mass in orbital motion can be found by combining the equation for orbital speed and the general kinetic energy equation. The total energy of a mass in orbital motion can be found by adding kinetic energy with potential energy. These two equations are not in the data booklet, so be sure to memorize them or at least know how to find them. Before calculating the total energy, take note that the equation for escape velocity has been rearranged to make v squared. The radius of orbit is 5 over 4r. Substitute this into the total energy equation. Rearrange it in a way to make v squared. Substitute to find the total energy in terms of escape velocity. The energy required to move the satellite to infinity is equal to the total energy in the orbit. Lenz's law is equivalent to the law of conservation of energy. Lenz's law states the direction of the electric current induced in a conductor by a changing magnetic field. If the direction of the induced current is assumed to be in the opposite direction, then a situation arises where energy is created and there is more energy after the changing of the magnetic field than before. 2 things to keep in mind. Number 1, the gradient of a displacement time graph is the velocity. Number 2, induced EMF is directly proportional to the velocity when the magnetic field strength and the length is constant. Now let's analyze the displacement graph given in the question. We can roughly divide the graph into 3 sections. In the first section, the gradient increases. This means that the velocity increases, which means that the induced EMF increases. In the second section, the gradient is constant. This means that the velocity is constant and the induced EMF is constant. In the third section, the gradient decreases. This means that the velocity decreases, which means that the induced EMF decreases. So now you should have a rough idea of what the EMF time graph would look like. Power loss is calculated by multiplying the current squared with the resistance. Increasing the thickness of the wires increases the radius of the wire. This increases the cross-sectional area of the wire, which means that the resistance decreases. When the resistance decreases, the power loss also decreases. This automatically makes statement 3 also true. Statement 2 is also true. Laminating the soft iron core reduces the amount of eddy current induced. This is an unwanted current that is induced in the iron core as a result of change in magnetic flux. The mean power dissipated can be calculated by using the equation given in the data booklet. Substitute in for the current to determine the power in terms of resistance and peak voltage. The process where a gamma ray splits into an electron and a positron is known as pair production. Here is a Feynman diagram of this process. Note that the opposite where the electron and positron met to become gamma ray is also possible, and this is known as pair annihilation. Electrons have quantized angular momentum. The equation for this is given in the data booklet. Rearrange to make the speed the subject. Use the data given in the question to derive equations for the speed of the electrons in each state. Put in the values, cancel out, and simplify to find your answer. Let's start by finding the nuclear density. The volume of the nucleus can be found by using the equation for a sphere. Substitute in the equation for nuclear radius and simplify. The mass of the nucleus can be found by multiplying the nucleon number with the unified atomic mass unit. Put these two into the density equation and simplify. We can conclude that the nuclear density is constant. Let's start this question by deriving an equation for the half-life. Half-life is the time taken for the number of nuclei that have not yet decayed to fall to half its initial value. Start from the equation given in the data booklet. Set the number of nuclei to half the initial number of nuclei and the time as half-life. Cancel out, inverse both sides, and ln both sides. Rearrange to derive the equation for half-life, which equals to ln 2 over decay constant. Now let's have a look at the graph. At time s, the number of decayed nuclei and the number of undecayed nuclei are equal. This means that half of the undecayed nuclei have decayed. This means that s is also the half-life. We previously found the equation for half-life. The expression for s would be identical.